In this video, you'll learn about how databases are designed and about validation. By the end, you'll be able to distinguish between entities, attributes, tables and fields, use a data dictionary to design a database table, explain the purpose of validation, describe the 4 different types of validation, and identify when validation is required. When we think of designing something, we often associate it with something artistic, like drawing a picture or designing a product. However, designing doesn't always have to be visual. It simply means planning something before it's created. Just like a painter creates a study and a sketch before completing the final painting, it's a good idea to plan a database before you create it so that you've got a clear idea of what data you're going to gather and where you're going to store it. When designing a database, instead of referring to tables and fields, we talk about entities and their attributes. When implementing a database design, entities become tables and their attributes become the table's fields. For each entity that we wish to include in our database, we create a data dictionary. A data dictionary details what attributes we will collect about the entity, the data types of those attributes, whether or not the attribute will become the primary key for the table when the database is implemented, and validation. One of the main benefits of using a computerized database to store data is that it's easier to make sure that the data is accurate. Remember, this is one of the implications of the GDPR. Database management software allows us to add validation rules to a database, which ensures that any data that is entered is accurate. There are 4 main types of validation: presence check, range check, restricted choice, and length check. Presence check is used to ensure that every record includes a value in that field. You may have seen this when filling in online forms. It's often shown by putting an asterisk next to the field title. It can also be known as required. Range check is used to ensure that the data entered falls within a specific range. This validation can be added to number, currency, or date and time fields. You may have seen it on fields like age or date of birth. Restricted choice is used when the value in a field must be one of a specific set of options. This is often seen in fields such as title or occupation. Length check is used when data is validated using how many characters you enter. This could mean that it must be strictly a specific length, or it could mean that it's got a maximum or minimum length. This is most commonly used for password fields. So let's create a data dictionary for a database table to hold information about pupils in a school. In this case, the entity is school pupil. When coming up with attributes, we're deciding which aspects of data we will gather about school pupils. In this case, pupil ID, first name, surname, date of birth and house. Pupil ID would be a number, text would be an appropriate data type for our name fields and house, date of birth would be a date and time attribute, and we would put PK in the key column for pupil ID to detail that it's the primary key. Remember, this is because each pupil has got a different pupil ID, so it will uniquely identify each row in the table. We also have to include details of any validation required in the validation column. We need to state the type of validation used and also any additional information. For example, we might want to add restricted choice validation to the house field so that it can either be Barry, Herring or Laurie. We may want a length check on the name fields to ensure that they're between 2 and 20 characters long. Our date of birth field needs to be within the years of school pupils, so we'll need a range check. And because our pupil ID column is our primary key, we want to make sure that it's presence checked. So now you've got an understanding of what a data dictionary is, and you can use one to design a database table. You also have an understanding of the purpose of validation and how to identify appropriate validation for database fields.